Hello everyone, welcome to this session. In this session, I am going to explain about the working of vane pumps which are used in the fluid power system. In the previous session, I have explained about the working of the gear pumps. And here the another types of the pumps, those are the vane pumps I am going to explain. And here first we'll take that is definition of the vane pump means the vane pumps are self-priming positive displacement pumps providing constant or variable flow rate at varying pressures. As we know that one gear pumps are providing the constant flow rate only. Those are called as a constant displacement pumps. And these are the vane pumps provide either constant flow rate or a variable flow rate. That's why these are called as a constant displacement or a variable displacement pumps, and these are also a positive displacement pumps so that whatever the fluid entering to the pump will be delivered positively without any leakage. And as the pumps are the prime source for the operation of the fluid power system, then here the what are the different types of the vane pumps are there. Vane pumps are classified as unbalanced vane pump, in that fixed displacement type, and second one pressure compensated variable displacement type. Then second one balancer vane pump. And first we'll take that is fixed displacement vane pump of unbalanced type. Here fixed displacement means it will be supplying the fixed flow rate, and unbalanced means here the inside rotor whatever is there and the camering of the pump, those are having the different axis. There is a eccentricity between the axis of these two, and due to that there is unbalanced force is acting on the pump, and that is called as a unbalanced pump. As vanes are we are using, that's why it's called as a unbalanced vane pump. How the working of this vane pump is taking place? Due to the eccentricity of the uh, this inside rotor and camering is there, that is the major cause for the operation of this vane pump. This is inside rotor and this is outside is the camering, and in the rotor the slots are provided, and within slots the vanes are inserted. Due to the centrifugal force which is acting towards outwards, and that will be caused to move the vanes within the slots in and out. And at this position we can see due to the eccentricity there is a gap between the rotor and the camering, and due to that the vane will be moving outwards, and that will be cause for increase in the volume, and there the whatever the oil or a fluid is there, that is trapped, and that will, whatever the volume of the fluid, the certain quantity of the fluid which will be there between the two vanes, that will be carried around the rotation of the pump. And due to the eccentricity, and whenever the vane is moving inside the rotor, and that is reduces the volume and thereby increases the pressure, and due to that it will be discharged in the delivery line. And this can be explained by using the this line diagram. Here we can see the inside rotor is there, and to that the drive shaft is connected. The slots are provided in order to move the vanes, and these are the vanes which are inserted in the slots. And whenever this uh, rotor is rotating, then these piston vanes are moving outwards, and those will be held against the inside surface of the camering, thereby providing the volume or increasing the volume to flow the fluid. And during its rotation it will carry the fluid around, and whenever the volume decreases due to the rotation of the rotor and movement of the vane inside the rotor, and that will be pressurizes the fluid in the delivery line at the outlet, and there decreasing the volume will be taking place. That is the cause for increasing the pressure and delivering that one. And here the displacement volume, how much is there? Okay, how much? This is the one rotation displacement volume, and how many volumes are displaced during one rotation of the shaft. That is the quantity of the fluid supplied by using this pump. This is the fixed displacement type vane pump of the unbalanced type. Moving further, the pressure compensated variable displacement vane pump, that is unbalanced. This is also unbalanced type. The forces are unbalanced, but it is a pressure compensated variable displacement vane pump. The flow rate will be variable in this one. As per the requirement, we can vary the flow rate, we can vary the displacement. Here this operation we can say in this video, that is, here the pressure will be supplied by the fluid or the movement of the cam ring. This inside rotor is fixed, it will be rotating. The cam ring position will be changed so that that can be have the maximum displacement at this position we can see, and that will have the minimum displacement by aligning with the center line of the rotor also. At that point it will be supplying the fixed quantity, and it will be whenever the maximum eccentricity it will be reaching, the maximum fluid it will be supplying. Okay, that at any position the eccentricity we can set, and that at that variable flow rate we can supply the fluid. And that is the operation here. Whenever the pressure is not applied, and by the spring uh, force it will be moving to the maximum eccentricity, and thereby the flow rate will be reaching to the maximum. And this operation we can see by using the this diagram also. The inside it will be cam ring, the vanes are there, and rotor it will be there, and here will be the inlet port. At this position the inlet of the fluid is taking place, and that is carried around during its rotation, and it will be reaching to this position maximum volume flow rate, and here the outlet port will be there, and outlet port there it will be discharging due to the decrease in the volume. And this is the displacement control, and here we can see the pressure, the moment whatever is there, the cam ring movement can be provided by using this piston, and this piston whatever is there, this will be by using the screw also we can vary, and we can supply the pressure by using the piston. By using the piston cylinder arrangement we can supply the pressure to move the position of this cam ring, thereby we can vary the eccentricity, and thereby we can vary the flow rate. That is the operation of the this pressure compensated variable displacement vane pump. And here also the forces acting are unbalanced due to the variation in the eccentricity, and that's why it is also called as a unbalanced vane pump. Moving further, next one, balanced vane pump. This is used for only the fixed displacement, means the fixed quantity of the fluid we can supply by using this one. And this, what is the difference is that it is a balanced vane pump. That means forces acting on the pump on the rotor are balanced here. How it will be provided? Here we can see that this is the inlet, and that inlet will be divided into two parts. At the two opposite sides of that rotor, the inlet we are going to supply, and this cam ring is made in such a way that the its space forming will be there, that is at the two positions, at the two positions which are opposite to each other, and thereby here also the fluid pressure will be acting, and here also lower pressure. At the exit there will be higher pressure, and due to that the balancing of the force which will be acting on the rotor it will be taking place by making the two inlets and two outlets. We can see here there are two outlets, and thereby here the more pressure will be there at the outlet, and those are also balanced. Thereby the balancing the forces will be taking place on the pump, and thereby the totally the pump will be balanced. That's why it will called as a balancer vane pump. Okay, it will be delivered here from the two outlets, and that together connected to flow the outlet to the system, make the flow of the fluid to the system. And here by the using this line diagram also the working we can see here. This is the inlet, and here the space is forming taking place due to the eccentricity formed by the cam ring as well as the rotor, and thereby the volume of fluid will be flowing in this direction, the volume will be go on decreasing due to the extensity of the camering, and here the pressure will be increases, and due to that pressure it will be delivered in the delivery line. And at the same time there is the opposite direction. Here also the certain volume will be increased, and thereby the that volume of the fluid will be carried after the exit during outlet during its rotation, and there the pressure will be increases due to the decrease in the volume, and that due to that pressure the flow of the fluid will be taking place. And at the two outlet whatever are there, those are connected to form a one outlet which will be supplied to the system, and one inlet which will be taking place. And here we can say this is the camering rotor, this is the rotation and vane, and volume between the adjacent vanes decrease in the outlets. Here the decrease in the outlets, here we can see at the outlet the decrease in the volumes will be taking place here. Here we can see this one, the decrease it will be taking place, decrease in the volume, thereby pressurizing will be taking place. Volume between the adjacent vanes increases in the outlet quadrants. At the outlet quadrants it will be increasing. Here the volume will be increasing that one, and thereby the flow of the inlet fluid will be taking place. And by that one the balancer vane pump is there, as well as it will be supplying the fixed quantity of the fluid only, and the fixed displacement type balancer vane pump working this one. And further, the another type of the pumps are there, those are called as the piston pumps. And in the next session, I'm going to discuss about the piston pumps. And thanks for watching. If you like, share, subscribe, and comment.